Hey guys, it's Miss Kennedy again. Right now we're going to talk about encounter 1, which was measurement. Okay, so just to begin with, we need to go over our SI units. SI stands for International System of Units. And we have to use certain units with certain measurements. So with length we use meters, mass we use kilograms, volume for liquids we use liters, solids we use a centimeter cubed or a meter cubed. Temperature we use Kelvin. The way we can determine Kelvin from degrees Celsius, which is what we measured our lab in, 0 degrees Celsius plus 273. Okay, so you will add 273. Time is in seconds. Okay, the reason why we use this is so that we have a standard system of measurement across the country, across the nation for the most part. Okay, now with temperature and with Kelvin, we have to pay attention because Miss Kennedy can give you an answer in Kelvin and ask you to convert to Celsius. So instead of adding 273, you would subtract 273. Okay? So with these things, how we come up with these units is through tools that we use. Specifically, we have used graduated cylinders to date, we've used thermometers, we've used triple beam balances, and also beakers. Okay? So I definitely want to make sure that we go over these things really quickly. A graduated cylinder is our most precise instrument we have used so far to measure volume. Okay? When we are using a graduated cylinder, we make sure that we are measuring, okay, not pouring out of a graduated cylinder to measure, okay? With the graduated cylinder, we measure at the meniscus. So that means we get eye level, looking at the liquid, and you'll see that it forms this nice little curve. So on this curve, we draw a line with our eye or with a pencil underneath that curve, and we count from there. So this one would be 4, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. 4.9 milliliters. Okay? Thermometers sometimes also have a meniscus depending on the size of the thermometer. So you have to be pretty careful whenever you're looking. Alright? Now in that thermometer that we use, that red stuff is not mercury. Okay? That we thought, oh, I've always used mercury thermometers and they're poisonous. That's why we don't use them. So the actual red stuff is alcohol that's colored red. Okay? Alcohol is a very low boiling point, meaning that it boils very quickly. So whenever we're heating, you can measure it up the tube. Okay? Our triple beam balance we've used quite often. I also gave you the website to reference as well if you want some interactive practice with that to feel more comfortable. Okay? These little blue things are the things that were on our rails are called riders, so they ride the rails. We start in the middle with our largest number, and you can see our rider is located at 200. Here it's located at the 60, so 260, then we go to our least number, which is 4. 264, and then we read the graduations as decimal points. 264.12, roughly 3. 264.3 grams is our answer. Now, notice how I use milliliters, notice how I use grams. We definitely want to make sure that every single one of our numbers, whenever we're recording data, has a unit. Otherwise, they're considered to be naked numbers. They have to have clothes, guys. Clothes are necessary. Okay? Finally, our beaker. Our beaker is used to pour or hold liquids. It's also used to mix, but usually we do a lot of our swirling in an Erlenmeyer flask. Okay, so a beaker and an Erlenmeyer flask can be considered one and the same in reality. They too have graduations. However, you can see that the graduations here are a lot less precise than these, okay? So a beaker is not precise, but however can be accurate. Let's talk about those words a little bit, precision and accuracy, okay? Think of a dartboard. If you're trying to hit a bullseye, okay, and you get 3 chances, and you hit the bullseye every time, Miss Kennedy rocks. I know. I am precise and accurate. Miss Kennedy tries again, and she only hits the bullseye 1 time, and the other 2 fall outside the range. So you could say that she's accurate, but not precise. And then she's definitely having an off day, and she hits none of the bullseyes. So she is neither precise nor accurate. Okay? So we use this information to collect data points on our graph, okay, which we're going to talk about in the next encounter a little bit. All right, but just remember, precision and accuracy is what helps determine the validity of an experiment. All right, all of this data that we've talked about right here falls in two categories, and these, majority of them fall in quantitative data. Quantitative data deals with quantity, all right, expressed in numeric form, temperature, quantity, how much, your numbers, how many M&Ms you had, okay, quantitative data. Qualitative data deals with quality, so our observations. Our observations come from our senses, our smell, what we hear, what we see, okay, what we touch. We don't necessarily taste things in our science classrooms, however you did get your eat your M&Ms, so thank you. Or you're welcome, I should say. All right, however, both of these lead to inferences, okay? When we infer something, that is based off a logical observation. So in our formative assessment, our checkpoint that we took, the ladies were walking down the beach and they had a lot of observations that they made. They made no inferences because they did not assume, or they didn't make any things, well, they didn't make an assumption based upon the salt water, okay? So inferences are based upon reasoning and or assumptions from observations. You can't have an inference without an observation, all right? Keywords there. All right, let me know if you have any questions in class, and hopefully I can help you later. Deuces.